Okay, so let's get started. Actually, we just like before, we'll make a brief the summary of what we achieved in the last month, and then give you a quick update of our status. And then we go on something new, and in the end, we will go through the last major release. So the first, as usual, our the community is still growing. So for the marketplace, we grew around 400 in 300 in the marketplace, and for the open basic extension, let me actually I think I can share the link. Anyway, I will do it later. So for the open basic, we grew around 10,000, and for the library, we keep growing very fast. We in the last month we grew around 4,000 packages. So we are still growing about, I believe that 30% per month. And we add another metric is the module. Module is a more cost growing unit, and we will see in the next month how it's going. So for new language, people keep asking us what's the killer feature for new language, right? Why you need a new language uh, for this? So I think we are now. I think we believe we found two use case which MoonBit will fit very well. The one is the full stack because the MoonBit can be compiled to the JavaScript and native and WebAssembly. So in the same language, you actually as we show you, we have our own cross-platform the UI framework. So that's one thing we believe is our advantage case. And the other is the cross-platform distribution thanks to our WebAssembly backend because MoonBit can be compiled to a very small WebAssembly and actually it's quite fast. So it's very easy to distribute your application to the Windows user and to Mac OS, right? And it has sandbox by default because then you can. This is very useful in the agentic area because now the agent run a lot of software, and if you are careless, then the agent will, then the software maybe will do some harmful behavior, like they remove some directories or upload your documents into the public cloud. So because of MoonBit, we compile to a very small portable WebAssembly platform, and it has a built-in sandbox by you, right? And you can run the WebAssembly with the dynamic policy. You can have a JSON file to say which directory are allowed to be read, and then yeah, it is give you a very lightweight sandbox. I believe it's very useful in the AI area. So actually, I want to make this useful. We have in the last release, I believe it's already available in our stable release. You have a MoonX. MoonX is very similar to the MPX and the UVX, but the difference is you have a MoonX. Then see, this is one example. We have an Office, which is a very light software. I think the Office is more than several hundred thousand lines of code. It's a very large software. It's basically the docx, and the Excel and the PDF, all the Office suite in a single movie library, and I compiled to WebAssembly. It's only 3.15 megabytes, very small, and then you can basically run the CI everywhere in your Mac, in your Windows, and it's portable, and it also have your sandbox by default. So this give you an idea how easy it is to distribute very large software in MoonBit, and you can run it everywhere. So this is something I'm very excited to make the MoonBit very easy to distribute. The other thing I want to share with you is our own agent, which is dedicated for MoonBit. It's called OpenSix. It's developed in public in the GitHub. We plan to release in August. Based on my user experience, actually, it's already very useful. For example, I try to fix the warnings in a very large repo, which has like the close to 700 warnings. 700 warnings. I ask the cloud to fix all the 700 warnings using the Opus 5 model, which is a very capable model, but it cannot fix all the warnings. It spent a whole day, a whole night to fix and then get stuck. But I asked the OpenSeek, our own agent, to fix the 700 warnings using the DeepSeek, which is obviously a weak model compared with the Opus 5, but the OpenSeek uh, finish all the job. So actually it is very encouraging, which means if you have a very dedicated harness, you can beat the powerful model. So we feel like this is very useful, and we plan to release officially announce it to the MoonBit users next month, August. That's our exciting plan we want to share with you. The other is that I mentioned in the last monthly announcement, we have our own cross-platform UI. It's also available on GitHub. So we plan to release in the next month, and we also have another cool stuff is we are also developed our MoonBit AI native IDE. So this is built on top of the two technology. It's a Moon Pilot and the Moon Desktop, because we have the cross-platform UI. So we based on this, we have our own MoonBit AI native IDE. This is not a wrapper on top of the VS Code. It's purely MoonBit. So the agent is built. The AI native IDE has an agent, right? It's built in the MoonBit, and that the cross-platform the desktop UI is also built using the MoonBit. And the way the yeah, we have also have a scale marketplace. It's also built in the MoonBit, because we can compile the software to the Markdown. So we are going to make it publicly available next month. It's a MoonBit AI native ID. Why we need a new ID? It's because the traditional ID is optimized for a lot of purpose, like to take the VS Code. Oh, MoonX is the MoonX is means that you can Moonrun is for local, so you have a so the difference is Moonrun is local, and MoonX is you have a username and have a package. When you publish your package to the mooncakes.io, then you can just MoonX run the MoonX is more like the can run any uploaded package. Yeah, it doesn't require any pre-installation, and if you are running by default, the MoonX run a Watson backend. So MoonX by default run Watson backend. When you upload your code, and we know it's a WebAssembly, it's a Watson backend. We just build the Watson backend for you, and we also apply the Watson OT, a lot of the Watson optimization to make it very small, and then you can just so when you download, you just grab a binary. This is unlike the NPX or UVX, you grab your dependency and your dependency. But for the MoonX, you just grab a library. You just grab a binary, then you're all set. So it's very fast. You don't need to have a dependency checking. Yeah, it's a difference. So let's get back to the Moon AI IDE. So why we need a Moon AI IDE is because the traditional IDE is optimized for a lot of purposes, like the editing, right? You allow your editing and give you real-time feedback. But the Moon AI native IDE is optimized for understanding. So we build the IDE to help you understand the AI slope. So because these days AI generate a lot of code, and if you don't really understand the code, in my opinion, the code doesn't belong to you. So my understanding of the AI is AI can help you to build a prototype very quickly, but it's not really your own code. For example, like this is the people can build a C compiler every day or every week, but now the C compiler is commercially useful. right? Because it's an AI slot. So when AI give you a prototype, you still need to spend a lot of time to improve the quality of the AI generated code, and you make sure you understand the AI generated code to make it maintainable. So the understanding the code is critical. So for our own AI native ID, we'll spend a lot of work to make it's easy to understand what the code is doing instead of and then we have an agent. We don't allow you to write the code. Actually, the editing the code is disabled, but you have to use our agent to do the addition. But we have a very good visualize the movie code to help you. So that's the main idea of the our own IDE. Yeah. So yeah. So that's the thing I want to share with you. Yeah, go ahead. So yeah, go ahead. You're welcome to ask any question. I can hear you. Yeah.
Yeah. Hey, uh, big things happen to my kind of workflow. Now well, let me share my screen so that we have some content. Let me.
Mm-hmm.
Okay, so I run. So my entire operating system runs now on MoonBit. So I have effectively folder here. So all these commands are in, and some have MoonBit calling native C effectively. So they call zero cost because of the compiler. Everything is trace. Everything is not in MoonBit is banned. And my big concern now, because what I'm trying to do is like, although usually the way I write code nowadays is that I reference the LLVM project, and I say basically find me the CPU instructions that minimize CPU cycles effectively, like down to the point where anything that runs slower than 5 milliseconds, like a bug, and then essentially an agent goes in a loop trying to get me to like physical limits on how fast I can run the code. My only issue, and maybe AI is lying to me, is that it says that there's an overhead of calling MoonBit because of the MoonBit runtime. And I'm trying to figure out how do I cut the runtime. Like what I want is like I want the speed, or like technically I want to use MoonBit, but I want to have zero overhead over C,
Oh,
even at the.
yeah,
That makes sense.
yeah.
I
So
want to
maybe yeah. Go ahead, please. Sorry.
Yeah, I just want to inline C effectively.
Yeah.
And
Mhm. Sorry. Go ahead. Sorry.
yeah, that's it. Basically, what I want is like I want to be able to get I zero overhead on all code that I run. So like I like the way I use MoonBit for now is like first of all, well there's a coded MoonBit, but all the right code is with specifications. All specifications are written and verified with Y3. Uh, in 4, I kind of got that idea from there, and
Mhm.
it looks like the functions. It has like a bunch of and then it says like, hey, this spec composes with this specs. And what I'm trying to do also is like I'm trying to push the type system so that like I give like so like the way like I say is like, hey, execute on this, and there's like some spec here somewhere, and it will run the agent will run something like execute. So we'll run execute command, which is like a MoonBit CLI, and it will take the spec and start executing it. But let's say I give this spec to some agent like an OpenSeek agent. So like it's not a very powerful model, but it has a good harness, sure. And what I really want is I want to encode like a physical hardware constraint into the type system. Like like for example, there's like a notion of what is it like L1. There's like L1, and there's like some amount of memory that holds L1. So like for example, I want to encode that the spec has to execute without bypassing certain constraints, like this constraints, for example. I mean, ideally this is solved by the language, but that's not the case. Like if I just give, if I just, for example, if I just write software with like a MoonBit core library, that is going to be fast, but you can get much faster if you start optimizing down to like very CPU instructions, right? And so what I kind of want is like I want to be able to kind of do that with MoonBit, if that makes sense. Right? I don't want to have any overhead on MoonBit the runtime, if possible. I'm not a compiler engineer, but that's like how like what I'm trying to build. So like just basically hardware limits on execution and have a very nice type system of MoonBit to work with, because MoonBit is very readable, unlike C. And it composes well, and there's like a lot of nice features, but like there's a slight overhead of the runtime. And I'm trying to like, yeah, I mean the compiler is not open source. Otherwise, I would just ask.
Actually, the thing to answer your question, I think do you know the NIM? You know the NIM language, the NIM lang. So the you know
Name.
the so the MoonBit is
Yep.
very close to NIM. Actually, the MoonBit garbage collector is also very similar to the NIM. So and we have a C backend. So basically, there's zero overhead when you call in the C because it's just in the same language, right?
Yeah,
So,
but I maybe I'm wrong. I mean that's what AI like. I mean I can show. Wait 1 second here. So I was just asking like, what is the overhead of calling different languages? So like for example in Rust, there's like this about a milliseconds, and I guess this varies.
if you call the C language, I believe is zero cost because it's just in the same language.
Okay, but
Hmm?
compiled without any runtime of MoonBit effectively, right? Like you can do that.
Oh, so we the MoonBit the garbage collector is very close to the NIM. It's you have a ARC and we have a cycle detection. So it's a runtime actually is very thin. That's not too much. Unlike the
Okay.
tracing, so the runtime is very thin. So I don't think
So,
that's will add up too much. Yeah.
what you're saying.
Yeah, cool.
Okay.
And yeah, so any other question? Oh, okay, okay. So the thing I'm really excited is we moved much further in the last month to make push the Watson the portable bytecode. So basically, these days you don't need to make any change to your code. For if you have to have a lot of I/O operation, you have a process calling, and then you can still compile the WebAssembly. So we lift the limitation of the previously, you only have the pure computation, right? You can only compile some library which doesn't have any I/O into WebAssembly. But in the last few release, we made a lot of progress. So any MoonBit code, essentially any valid MoonBit code, can be compiled to the running WebAssembly code. So how does it work? It's because we have our own runtime. So for all the I/O operation, we support in our own Moonrun runtime. So you can for the platform different behavior we have our own Moonrun times for the WebAssembly for the Windows we have a uh, uh, yeah, so that's the thing. So the question how DeepSeek is a OpenSeek. So basically, OpenSeek is not really tied to DeepSeek. Basically, you can try other models. You can try the other model. But why I'm telling to use DeepSeek because DeepSeek is too cheap. So basically, for OpenSeek, you can just switch any models. But I found the only DeepSeek is affordable now because you don't just look at the pricing because for example, DeepSeek V4 Pro is like the 3 times cheaper than maybe 4 times cheaper than Cloud Opus. But the DeepSeek has a very cool stuff with the caching. So if your input is cached, then basically it's zero cost. And the cache hit can be very high. So in the OpenSeek, I have benchmarked the cache hit is rose 99% 9. So basically, when you use the OpenSeek with DeepSeek, it's almost free. You don't need to worry about the token pricing. So that's why I'm a big fan of the DeepSeek, despite it's maybe not as
Well,
capital. Yeah,
I have a question. What do you use for isolation of the agent? Do you use like a firecracker or something?
So sorry, isolation. We use we are going to adopt. So we have a sandbox. So you cannot do any arbitrary commands, and we are going to use OpenSeek for all the OpenSeek will use all the write all the code in the MoonBit. So OpenSeek you OpenSeek.
Oh, so it will use the WebAssembly environment.
Yeah, use the OpenSeek package to give you a safe guarantee because the OpenSeek we just emit MoonBit as a script language. So OpenSeek also use the MoonBit as a script language to do the automation, and then because it has a WebAssembly sandbox, so give you the safe the behavior. Yeah. So for the OpenSeek we are as I said, it's just too cheap, and we believe it's a intelligence will grow over time. So that's why we use the and we can even give it for free for the user. We are going to give a watch list. So if you use the OpenSea, we can give you for free because that's too cheap. That's the main motivation. But for the agent itself is not tied to the DeepSeek. You can basically bring your own key. Yeah.
Have you tried to use Kimi? Because that's a big model.
Kimi is still too expensive. Yeah,
Okay.
despite the Kimi says is less expensive than the cloud, but Kimi is still way more expensive than the DeepSeek. That's my number. So I believe the Kimi is 10 times more expensive than the DeepSeek.
Yeah, I mean it's a massive model, so.
Yeah. Yeah. So.
Oh, another question. By the way, sorry to interrupt. I realized last time I wasn't sharing my my screen. I just want to share like the. Do you see my screen now?
Yeah, I see your screen. Yeah.
Yeah. So this is what I meant with like I execute. So these are all the commands. This is all MoonBit. So this is all MoonBit. There's like a native C that it gets called sometimes. And so I execute in specs. The specs look something like this. So they provide like signatures, and then they have the requirements. And these are currently verified with Y3, the formal verification. And I'm kind of curious, like aside from Y3, do you recommend anything to improve correctness of code further, or Y3 you think is like enough? Let's say.
Actually, this is internal project where it's not ready, but we are developing our own theorem prover to replace the Y3. But it's too early to show you. Yeah.
So, but with theory proving, can I constrain the performance of the executed code, or I can only verify correctness? Like if I want to say that this OpenSea agent has to use only specific CPU instructions and does like should not go beyond like L1 cache, for example. Can I enforce that?
So back when I was a student, my professor told me you can encode the type system to make sure the algorithm of the program is a polynomial. So you can do some very fancy stuff to give some constraint to the program. But I think it's too theoretical, too theoretical to be useful. Yeah.
Okay, that's cool. Thank you.
Yeah. Cool. So that's the main thing I want to share with you. And we are still don't have too much time, but we're still trying to prepare the 1.0 in September. It's very tight, but we're still trying to hit the deadline. So the main remaining, I believe the language itself is the most done. So the main remaining work to get the async IO into the standard library. So that's the main block where we don't want people use the download the async library from so that's the main blocker. We are working hard to make it available, and we have a major break change. We have a major break change in the last release. It's not activated by default, but I will go through with you. So there's one major break change is called you see that we have a Moon explain, right? Dynamics is called new warning called the implicit impel as a method, and we write a very long paragraph to explain this breaking change. So that's the last major breaking change is but it's not activated by default, so you don't feel it. But in the next week we may activate, so you will feel the pain. but anyway, we have to do it. So previously, when you declare impel trait for type, then the trait method will be automatically attached to your type. You give you a method for free. But this is not very good for the refactoring because these days using AI agents, you want to have a lot of the do the fairness refactoring, right? This is implicit behavior. And then another thing is when you are trying to move the impel trait around, then it will be broken. And another downside is for the generated MBTI, because this is implicit, so it's not reflected in the MBTI. So you cannot just inspect the signature file to say, oh, how many methods does this type have? Because it may come from another trait. So we want to make it explicit. We want to make it explicit because if you really want to make the trait method as a type method, you have to write the extend type with the train method. That's the so we want to make it more explicit. It's slightly more verbose, but I think it's okay because nobody write code in this is AI write all the code, right? So we will be slightly more explicit. And we have a transition period. You have to so the transition period you have to declare extend. But if you don't really want to promote the train method to a method, then okay, yeah, good question. So we'll write a post. So basically, I can give you a very explanation. Previously, you have to impel shoe for int, and then you have to extend shoe extend int with shoe to string. Then you can use the x dot to string. That's the motivation. Otherwise, you have to use the shoe to string. So that's the so basically to make the so basically the your trait will not be the types method by default. You have to make it explicit or say, or this trait method will be the type method. You have to declare the promotion. So I'm not sure if my explanation is clear or not. Is it clear? Oh, yeah, I think I really last post the DeepSeek on Hermes spends that's almost impossible. But I think it's possible only when your agent doesn't take advantage of the caching. For example, I give you one example. For example, some agent in the system prompt will have a time step, right? You give a time step, and then because it has a time step, then all the system prompt is out of cache. That's the so if you want to use the DeepSeek in an economy style, then you have to make sure the system the agent is optimized for the caching, so you will not mutate the will not mutate the composition. So you have to respect the caching. That's the way to use the DeepSeek in an effective style. So so this is the largest breaking change. And maybe in the next week we will enable by default. Then you will not break your code, but it will give you a lot of warning. Then you have to fix it. And then we want to make the OpenSea give you, and then the AI will fix it for you. Okay. So and then another cool stuff I want to share with you is the with pattern. I really like it. So previously when you pattern match two branch and some branch miss some variables, now you can write the none with x equals 0 to make the balance. Then you can share with the continuation. This is very useful for the nested pattern match. I can give you example if you have the match a dictionary, and then have a key, key one. You have key one, and which is none with x equals 0, and then we have sum x, and have another key 2. Yeah, so the cool stuff with the with pattern, when you have a lot of nested pattern match, you have a lot of keys, and then otherwise you cannot use pattern match because they have to do a lot of branch default. So we use the with pattern. You can pattern match with the key value pair in a dictionary very easy. So this is a small feature, but I think it's really nice. Yeah. So another thing is as we said, we want to make sure MoonBit has make sure MoonBit has explicit semantics instead of implicit because the AI prefer the explicit. So we previously the iter it had a implicit, which just use array as a iter. We use a explicit iterate syntax. So you want to use the iter literal, you have to write the brackets with the two vertical bar. That's the slightly minor change. Another quality of life improvement is the array spread interpolation. Previously, you have to always have an else branch, right? Else branch to Now you don't need to just dot if condition then extra. This is really nice, but it's also backwards compatible because without else it used to be a compile error. We just remove the compile error so you can do the string interpolation nice. Yeah. So another thing is for companies we have a bias interpolation. This is not really used a lot, but it's just to make it complete with the on par with the string interpolation. Oh, another thing I really like is now the customer constructor can now be defined for any type. Previously, you can only use the customer constructor for the struct. Now you can use it for enum. You can use for basically any type. And because we have check mode, so you don't need to write the type in most cases. So it give you in my opinion, I really like it. So this is a small improvement. Another thing is also explicit. We want to make the language more explicit. Previously, the empty is an empty map, but in this case, like in this large dictionary equal map, we want to make sure you write the map just like write map to make it more explicit. This is a small change. Oh, this is a big change. It's a really something I really like it, and I think we finally nailed it. It's give the string first class regex expression. So we have this is still experimental, but we will make the major feature maybe in the next week or next or 1 or 2 weeks after. So you can pattern match the string, just use the regex expression, and you have before after. This is a purely static. And purely static, and you can, and of course, because it's purely static, it's very fast, and it also give you static analysis. Give you, we are working on it. So you have the multiple regex expression, and if you have some branch which is unused because some regex expression is covered by another regex expression, right? The branch is unused. We give a static warning to say, oh, this regex expression never is not covered because the previous expression will always be hit before the next regex is hit. So it's just like the pattern match, give you a full static analysis. And now another cool stuff is I think it's not here. You can have multi-pattern match. So and you can do the lex analyzer just in MoonBit. You don't need to in other languages like OCaml or Rust. You have to write a separate tokenizer file, and then here will give you tokenizer for free in the language. Very convenient. Another thing here doesn't mention you can have a regex expression and plus another one. So it's composable. So you can just lex scan regex composable. So it's not just the one time. You can share the constant regex expression, and yeah, you can. So I remember. So this is our last major feature, I believe. We will make it available maybe 2 weeks after, maybe next major release. Oh, so this I really like it. I hope you. And it's also composed with composed with our own already existing regex expression. So if you only have a single branch, you can do this if str. So this is a completion. So it's a complement of the existing regex expression, making the registering is more powerful. So the idea is MoonBit will be a very good script language. So we want to make a MoonBit to be an ideal ideal scripting language. So we believe MoonBit because MoonBit has a very good support for the JSON, right? We have very good support for JSON. Now we have very good support for the strings for the string processing, and then because we have a very safe by default the sandbox mode, so we think MoonBit will be an ideal scripting language. And now we want to use the OpenSig agent to just run MoonBit. You don't need to write Python or JavaScript. MoonBit is as good or even more express than the idea is to be there. So we spend a lot of work to make the stream processing ideal. Yeah, that's I'm really excited. And there's another one is some deprecation of the older JSON configuration. So we plan to remove the JSON file and just use moon.pkg and moon.mode. Oh, this is a minor thing, I believe. Yeah, just make it easy. And our native backend is available on Mac OS. And then in the next release, we make our own, just our handwritten native backend for the Linux. Then we get the Windows. Hopefully, it will give you faster compilation. Yeah, that's the for our tool train.
And for the native backend, you basically lower to C-lang, right? Like C-lang is doing all the.
No, C-lang, just to the mesh, to the native, to the assembly code, to the
But the
machine.
C-lang is doing the compiling, right? The final.
No C-lang, just no dependency on C-lang, just load to the machine code.
But what if you want to do some C-lang optimizations? Can you do that?
Oh, so this is for the this is not ready for release mode. It's for dev mode to give you a faster compilation. So this is not for the release mode. So currently for release mode, we still use Clown because it is faster. Yeah. And yeah, we have some improvement for the Windows. And yeah, we have another is previously you have called option is main, which is really weird. Now you can declare the package as a executable, and you can build a shared library using the MoonBit now, because we have called one thing called a foreign library. Foreign library means you can export some function, right? And you can export some function. Then we respect the ABI. Then you can compile this and just make the MoonBit library available to the C users. If the MoonBit library is available to the C, then it basically MoonBit is available to a lot of language. So that's another foreign language is currently still using the C compiler. Yeah, currently still use a C compiler. Yeah. Cool. So we have another tweak for the formatter for the configuration. So instead of writer option, now you have a dedicated field. We have some improvement to SP, and the other thing is, as I said, because now all the MoonBit library can be compiled to WebAssembly, so we build a website called skills, called skills mooncase.io. So every command, which is command, will be collected and make to a skills by default for you. Yeah. So. Yeah, I will not go through very detailed to the library improvement, but the idea is we will try get the MoonBit long /async into the core eventually in the next 2 months. Cool. Yes, I think that's pretty much the main thing I want to share with you. If you have any question, I can take 1 or 2 questions. Yeah. Do you have any question? I'm very happy to answer if you have any question.
I have a question. So in the era of AI, because you mentioned that you are trying to move to a stable release of MoonBit, like a 1.0. Do you think this whole 1.0 even makes sense in the age of AI? Because like migrating is really easy. Like I feel like doesn't it limit you to set something in stone?
I think the bottom line, you have to make sure that the syntax is stable. If the syntax is not stable, then the AI will struggle. That's the maybe the libraries. If you have this, we already have some attributes, right? Give you a good warning message or good error message, but I still believe the bottom line is you have to make the syntax to be stable, not changing syntax.
Because like I guess like for example in Golang they're still paying for 1.0 because they have some, let's say, mistakes that they did, or like maybe like not adding genetics soon enough, let's say, and that sets the language on a certain trajectory, I guess, is what I.
Yeah, I think the bottom line is to get the syntax stable, not change the syntax. Previously, we have error handling. We used to call the bound for the error handling. Then AI is still struggling to use the bound for the error handling. So yeah,
makes sense.
So the syntax have to be stable. So that's I see in the chat room, the Misha asked before. I want to know how your information ID evolving. Yes, that's I believe actually. The VS Code doesn't have a mode. So I think the VS Code is not relevant anymore. So that's why we decided to build our own IDE. Because and actually the workload of building your own IDE it's not that much because you don't need to do a lot of work to make the addition efficient. You only need to spend a lot of work to make it's easy to to understand the code, right? So there's a lot of complexity is gone. So the Moon ID is yeah. So my vision is the ID will go to a new era where it will help you understand the code instead of help you edit the code. For example, the auto completion, I don't use the auto completion anymore because I don't write code. So that's I think there's a big opportunity to build an ID. Yeah, there's a big opportunity to build an ID to understand the code. So that's why we started it's unbelievable. We just make the MoonBit ID full stack in MoonBit in 2 or 3 months, and it works pretty well. So yeah, so I think there's and because we only optimize for one language and one tool chain, right? So our we can move
Will I be able to still work with, let's say, C in that IDE, like the C language?
Maybe we'll give you some syntax coloring, but we don't do anything fancy.
Like I get that you are optimized for MoonBit, but it would be nice to potentially just like at least work with some language.
We have the Markdown or HTML or JavaScript, but we don't do any like semantic stuff for other language. We optimize for MoonBit. Yeah, that's cool. Yeah, so the ID, I think VS Code is not relevant actually, things are moving so fast. Cool. Any other question? All right, thank you very much, and I really look forward. The movie is still evolving very fast. I really look forward to seeing you next month. Have a good day. Bye bye.